first thing that we're going to start with is this ninja question. Well, I called it ninja question reading, but I've changed my mind. I want to call it ninja question analysis. And the reason that I've changed my mind is because I'm sure that lots of you have been told many times by your teachers, you've got to read the question carefully, and you kind of throw your hands in the air and say, I did. I read the question carefully and I still didn't get the right answers. And the problem is that it's not really reading. You've learned in the last sort of 17, 18 years to skim read, and it's a habit now, and it's a really good habit to be in. I mean, it's a really useful thing to be able to do, is to skim read. It's helpful, but skim reading means that actually when you're reading something, you only read about every third word. And you can't afford to do that in an A-level physics exam, because the prose that you've got to speak, to read is data dense. And if all you do is read it, what you'll do is only read every third word, and you'll get the gist, but it's only the gist, and you're going to miss things. You're going to walk all round what you should be doing. You're not going to have carefully examined what it is that the question is telling you to put in your answer. So we are going to go through the ninja question reading analysis. So this is analysing any question so that you know what's on the mark scheme. That's my cunning plan. So that's what we're going to do now. So here it is. Here is my ninja question analysis. Right now, I've got on the right hand side, I've got an example question that I thought that we could just have a little look at while we're doing this. But I'm going to give you some other examples in a minute. Okay, so this is the ninja question analysis. Right now, I do recommend that you get yourself a highlighter pen. You're not allowed to use a highlighter in your answers on your real A-level because they scan them in and it doesn't show. So you're not allowed to use a highlighter in your answers, but you are allowed to use a highlighter in your question. And one of the things of using a highlighter, especially when you're practicing, is that the act of actually highlighting, physically highlighting words on your paper page, that will slow you down. And that's the first thing you've got to do in order not to skim read. Okay, so we're going to highlight these things. Okay, so what is the topic of the question? Okay, so I want you to just look at this question, my example on the right hand side, and I want you in the chat to write down what the topic is for this question. Oh, yes, absolutely. Okay, so loads and loads of you have said moments. Yes, it's moments. Moments of forces. Yes, moments. What was the clue? What was it that told you that this was about moments? Well, it's quite clear with this one because there's a seesaw, and you always have seesaws in moments. You did at GCSE. It's not always the case, but there's clearly a seesaw. And can you see there? Oh, I didn't need to do that. Can you see that there is? Oh, why is that not working? Annotate. There we go. Sorry, I apologise. My annotations thing wasn't working. Right, can you see that we've got the word moments in there? That's a really big clue. So I would normally, let me put it in highlighter mode, I would highlight the word moment, okay? Because that's what we need. We need the topic of the question. Right, now, the next thing is we've got to figure out what the command word is. Okay, the command word is the word that tells you what to do. It's something like explain or describe or calculate or deduce or suggest or compare, or what, those words, those ones that tell you what to do. What is the command word for 17A? Put it in the chat, and Tom is ahead of the game. Oh, that is really cool. Oh, excellent, excellent. We've got the word calculate. Okay, so this is a calculate question. Okay, right now, the next thing to notice, can you see I've put in brackets, is it a show that question? Show that questions are really useful because They use show that questions to make you realise that you're going to need the thing that you're going to show in the next bit. They use show that if they need to give you the answer, because you can't do the next bit without it. So can you see show that questions? It's a really big flag. It's saying you're going to need to use this number in the next bit, right? Or this relationship, whatever it is you're showing, right? So that's a really big clue. The other sort of question is a signpost question. Now, there isn't a signpost question here, but a signpost question is one of those where it says state Newton's law of gravitation or something, and that's a signpost. That's kind of like neon lights flashing at you saying, this is about Newton's law of gravitation. This question, you're going to need that law. Can you see? It's really big clue. So it's a signpost question, but we don't have one of those here. We do have the word by taking moments, so we know that it's about moments, okay? Right, now, having done 1 and 2, the next thing that I recommend that you always do is get out your data sheet and open it at the relevant equations. So the relevant equations for moments would be the Newton's laws bit, the mechanics bit of your data sheet. And I'm hoping, fingers crossed, certainly my students ought to have a data sheet right next to them right now. And one of the things that I would love for you all to do is to print out about 5 copies of your data sheet, and I mean that, and put 1 in your school bag, 1 in your locker, 1 in the front of your physics folder, 1 on your dining room table or your kitchen table, wherever you work, 1 on the back of the loo door, 1 in the coat pocket that you use when you're riding the bus in the morning, right? I want you to have a data sheet to hand so that when you're waiting for the ads that are now on Amazon Prime to go away before you watch the next episode of your favourite thing that you're binge watching, I want you to get out your data sheet and I want you to look at it and I want you to start learning, not the equations. You've got those. What you need to know is what every symbol in every equation means. And all of them are used more than once. So capital T might be period or temperature or, what was the other one? Tension. Yeah. Capital A is used for area or activity, nuclear activity, or the mass number. And even the Greek ones are used more than once. So lambda is the decay constant in radioactive decay, but it's also wavelength. Okay, I mean, they're all used more. Every single letter is used more than once. Even Z. Z is the redshift and also the number of protons. Okay, it's also the attenuation coefficient for sound waves. Okay, interesting, right? So all of them are used more than once. And what you've got to do is you've got to be able to look at an equation on your data sheet and go, well, that C means specific heat capacity, and that C means the speed of light, and that C means the average speed of a particle, and, right? So you've got to be able to look at them and figure that out. Right, so you're going to get your data sheet out, and when you've got your data sheet with the relevant equations right in front of you, you're much more likely to spot an equation that you might need. Sorry, most squeaky door in the world. You've got much more likely to spot the equation you might need for your actual your question. Okay. It also, if you've got to use more than one equation because you haven't got one equation that's got everything in it that you need, you might be able to then substitute, because you'll notice that omega is 2 pi f and you're going to substitute that in, and because you've got the frequency you don't have omega, for example. Okay, right, next one. The next thing you're going to do is you are going to highlight the numbers in your question. Okay, so I'm going to go through and highlight my numbers. I've got 35 kilograms, I've got 650, 550, 1.2 meters, 0.5 meters, 2.1 meters. Or have I got any others? Okay, I've got 1.2 meters, 0.5 meters and 2.1 meters on my diagram. Anything else? Anything else? Anything else? Think that might be okay. Right, now, having done all the numbers, now what I want you to do is I want you to highlight the words which indicate numbers. Now, actually, in this particular question, there aren't that many. You could use the word balanced. You could highlight the word horizontal, because they both indicate, I mean, it's not exactly numbers, but it sort of is. Okay, and you've got the center of mass. They've told you where the center of mass is. Okay, remember that the center of mass is where the weight appears to act. Okay, so and it's above the pivot. So we could, I'll change my color. We could put in the center of mass there. It's that blue blob, right? That's where the center of mass is. Can you see that's information? So those are words that sort of indicate numbers, but there are other words, the words that hide numbers, but they come up really frequently.
At rest.
Yeah, the words at rest. That's really, really cool. Or if things are released at the same time. Okay, that's numbers. There's the words each, especially when it's linked with the word second. Okay, so each second, what they're telling you is that something is happening in 1 second. That's a number. Ooh. Okay, you also want to highlight relationships. So they say that F is proportional to A, for example, or they'll say that that T squared is proportional to R cubed, for example, or they'll say that the word half or double or squared or any of those, anything that indicates relationships, all of those are very important. There are one or two that hide even then. So the word recoils, for example, it gives you the direction of a vector, the momentum or the velocity vector of the lorry after the cars, or the car after the lorries hit it, or something, or maybe the nucleus of radioactive material when an alpha particle's gone one way and the nucleus recoils. It tells you the direction of a vector. That's a number. Okay, so I want you to go through and look for the words that are actually numbers. And I don't think there are any others. I don't think we've got any others in this particular example here. Okay, and then and only then do we read the question for meaning. And when you're reading the question for meaning, what I want you to do is I want you to either draw a diagram, might be a circuit diagram, it might be a force diagram, it might literally be all parallel plates and an electron between them or something. It might be, you know, a man jumping out of an aeroplane or something like that. I want you to actually draw it, just do a little sketch, because it makes things much clearer when you've actually got your fireman sliding down his pole, or, you know, you've got a spaceship with an iron drive firing irons out one way or something, right? You draw a diagram. Right, now here we've got a diagram and we're not going to redraw it, but what we are going to do is we are going to add information to our drawing when we're reading the question for meaning. Okay, so we are going to add information to our drawing. And so I'm going to read what it says. It says, the diagram below shows 3 children. Oh, look, I missed that word. 3. That's a number. Missed it. Okay. A, B, and C. They're sitting on a balanced horizontal seesaw. The mass of the seesaw is given. Right now, because we were going through and noticing words that were sort of numbers that weren't, we know that the centre of mass is above the pivot point. So we could put there our force, couldn't we? Which is the weight of the seesaw, which is W, and of course W is mg, and M is 35 times G. Okay, I've put it in. I've read for meaning. I've added it in. Right, the next bit, okay, the centre of mass is vertically above the pivot, so we've put the force in the right place. A has a weight of 650 newtons. Right, I'm going to put the weight of A in. 650 newtons. Okay, B has a weight of 550 newtons. B has a weight of 550, running out of space, newtons, okay? And sits 1.2 meters from the pivot. Well, they've put that in for us. Can you see? And B sits 0.5 meters from the pivot, and they've put that in for us. There it is. Can you see it? Okay, so then they say C sits 2.1 meters from the pivot. Okay, and that is also in there. So I don't need to do that. But I'm noticing things now. Okay, they want us to take moments about a suitable point, and they want us to calculate the weight of C. I haven't put the weight of C in my diagram. I'm going to add it in because I'm reading for meaning. There is the weight of C. I'm going to write down WC. Okay, that is what I'm trying to calculate. Okay, so now I've read it for meaning. I've drawn a diagram. I need to look at the number of marks now and see whether or not there are either a surprisingly large number, which tells us something, or a surprisingly small number, which tells us something, or the appropriate number, which also tells us something. Okay, so how many marks? Well, there are 3 marks, you see, down here, for this question. And it's a regular moments question, but there are 4 forces. Okay, so 3 marks, okay. So what are we going to do in order to answer this question? Okay, what's the next thing we're going to do? What equation or principle or sum can we do to answer this question? Put it in the chat. Oh. Okay, well, we've got M is FD. I'm slightly bothered about you using M for moment. Technically, you're going to hate this. The symbol for a moment is T, capital T for talk. Oh, it's another use of capital T. Yeah, not good. Oh, and we've got some principles coming through. Excellent. You can see it took a bit longer to type those. Yeah. So yeah, absolutely. We're going to use the principle of moments. So everybody that put M is FD, you can have a star. Everybody who put the sum of the clockwise moments equals the sum of the anti-clockwise moments.
What about the funny P?
Oh, the funny P is not moments. That's momentum. Oh, and Catherine, I'm so glad you said that because so many people get it muddled up, including me. I mean, the first 6 letters are the same. So absolutely, I'm so sorry. I shouldn't bring attention to it, but you're absolutely right. The funny P is it's momentum, not moments. Oh, yes. Yeah. Okay, so we are going to use the principle of moments, right? So we're actually going to do this, right? Right. So the clockwise moments equal the anti-clockwise moments. I'm always in the way. Moments. Okay, and that's the principle that we're going to use. What pivot point should we use? I mean, it's pretty clear here. Because there's a pivot. It's pretty clear what we should use. Okay, so I think that we should pivot around the pivot. Okay, so which of those forces gives a clockwise moment about my pivot? Which force? Yeah, C, WC. Oh, the other ones are anti-clockwise. Imagine, if you will, a clock. It goes well. It goes clockwise. That's not really helpful, is it?
To the right. From the top.
From the top, it goes right. Yeah. So from the top, it's this one that's going clockwise. Okay. So we're going to do WC, and then we've got to multiply it by the distance from the pivot. and it's the perpendicular distance from the pivot, so that's got to be right angle, which it is, so that's okay. So times 2.1, okay? And that is the only force that makes it go clockwise. We've got anti-clockwise moments now, and W is through the pivot point, which means that it has no moment. Its distance, perpendicular distance from the pivot, is 0, which means it has no moment. So we've got 650 times 1.2, because that's the distance of A, plus 550 times 0.5, because that's the distance of B. And now you can just solve for WC. If I cross multiply, I can cross out my 2.1 and put it underneath there. And now that is the sum that I've got to do. Okay, and you plug it into your calculator in exactly that way.
We've got answers.
And oh, okay, we've got some answers, have we? Okay. Oh, we've got 502. 502.4. Okay, 502. Right now, I know this question doesn't ask for specific, for significant figures, but if it did, what would you answer? If you had to give this answer to the correct number of significant figures.
3, 2, 3, 3, 2.
Oh, is it 3 significant figures or is it 2?
2 as a min number of significant figures in question. 2, 3.
Oh, well done, Nathaniel. Right.
It's left 2, 2.
Okay.
2, 2.
It is at least 2. Okay, because there are 2 significant figures for every number in the question. Oh, except for the 0.5 meters. That's only 1, isn't it? So
it's only 1, but that's because it's a fraction.
Well, maybe. She's saying it's only 1, but that's because it's a fraction. Right, now
I would say that the 0 is a significant figure, because without the 0 you don't know.
If the 0 was afterwards, it would be, but before the decimal point, it's just a placeholder. It's like the 0 in 650 newtons. That is a placeholder as well, and it might be significant. You can't tell. Right, and that's the problem. Okay, so this is not a good question to talk about significant figures on, because it's not consistent. It's not even internally consistent. So it's actually very, very difficult. If you have a question like this where they don't ask for significant figures, any question where they don't ask for significant figures, routinely give 3. It's always easier if you just give 3. Very rarely do you need to give more than 3. And when they ask about significant figures, hopefully they'll be internally self-consistent with the number of significant figures, and it will be easy to answer. Okay, so I mean, if they did ask it here, I'd give 2, because most of those numbers are to 2 significant figures.